Hello guys, today we're doing LeetCode question 349, intersection of two arrays. The question is, given two integer arrays, nums1 and nums2, return an array of their intersections. Each element in the result must be unique and you may return the result in any order. So this tells us that we have to use a set because set contain only unique values. Now example 1, input is nums1 and it's an array of 1, 2, 2 and 1. Input 2 is nums2 and that's an array of 2 and 2. So the output is 2 because there's 2 in both arrays, and although it's there twice, as we only return unique values and then we return 2 once. Example 2, nums1 is an array of 4, 9 and 5, nums2 is an array of 9, 4, 9, 8 and 4. So the output is 9 and 4 because they both there's 4 and 9 in both arrays. 4 and 9 is also accepted, which means we take them in any order. So the fact that we can only take unique values means we have to use a set. A set is like an array, but there is only unique values. So the way we'll do this is, here we have nums1, which is the first array, and nums2, which is the second array. We'll first initiate a set, we'll call it set, and into that set we'll pass the values of nums1. So as it's unique, this set will contain 1 and 2. Then we initiate another set, and we'll call it final set, and that will be an empty set. Then we'll loop through, either string is fine, so we'll just loop through nums2 for now. Yeah, well, because we set nums1 here, then we have to loop through nums2, but you can do the opposite as well. So we'll loop through nums2, so we have an I value set to 0. We check if nums2 is in the set. If nums2 is in the set, then we'll pass it to the final set. So now we're at 2 for nums2, and is nums2 in set? Yes, it is. So we add 2 to the final set, and we increment I. The final set now has 2. And now we increment I is 1. Now, we are at 2 again. Is 2 in the set? Yes. So we add it to the set anyway, because that's the function. But because it's already in the set, it won't add a set as only unique values. So now we finish looping and we return the final set as an array, which means we return 2. And let me show you how we do this in code. So first thing we do is we initiate a set. So let set is equal to new set, where we pass nums1. Then we create another set, which we call final set. The final set is equal to new set. Now, you can also do this reverse and put nums2 here and loop through nums1. But now we're going to loop through nums2. You can't loop through the same number. So we have to, if you put nums1 here, you have to just loop through nums2. If you put nums2 here, you have to loop through nums1. So now we'll loop through nums2. So for let's do num of nums2. Nums2, we check if set dot has. So if set has the number, then we add it to the final set. So final set dot add nums2. Sorry, num. Now after looping, we know the final set will only contain unique values. We've added all the values of num1 here. We'll check all the values of nums2 here. So only the unique values that match will be set to the final set. Then we return an array from the final set, because this is expecting an array value, not a set. So if we return the set, we'll return false. So for now, array from set, final set. Let's see if that passes. Final set dot add nums. Oh, sorry, num, not nums. Now let's run. As you can see, it passes. Let's submit. Perfect. As you can see, this is a time complexity. Well, this beats most people with time complexity and most people with space complexity. This is a time complexity of on and on times om. This is on for nums1 and on as we're looping through nums2. So that's on and om. So on of nums1 and om of nums2. And our space complexity is again on of m, or the minimum of on of m, because we're storing the minimum between the numbers that match between nums1 and nums2. So worst case, it could be all of on or all of om. Thanks for watching.